Hello, my name is Jacob Huber, and I'm going to introduce our company, Sound Energy, today. We have a technology where we take heat, we convert it into cooling, so this means we can take what is a waste product and convert it into profit, and I'll talk a bit more about that. So what is the specific problem we're addressing? Well, we're looking at the maritime sector, which accounts currently for around 3% of CO2 emissions globally, but this share could go tremendously to 17% by 2050. The maritime sector also accounts for a very large proportion of nitric oxide and sulfur dioxide emissions and is very wasteful. This is due to the fact that more than half of the fuel that is burned is simply lost as heat through the exhaust and radiators of ships' motors. At the same time, the maritime sector has specific needs. There's no near-term alternatives to fossil fuels, and there's a general lack of cost-effective solutions for emission reductions. Where do we come in? What we do is we take the waste heat from ship's exhaust and we convert it into cooling to reduce electricity consumption and the fuel burned on a ship. This means we can provide up to an 88% decrease in electricity consumption and emissions relative to the use of electric chillers on a ship, which translates overall into up to a 12% overall fuel burn and emissions reductions on any given ship. So beyond this specifics of our technology, it's also very clean. We don't make use of toxic refrigerants or chemicals as electric chillers do. It's flexible, it's reliable, and it has no moving parts, which means basically no maintenance, which generates more savings over the lifetime. And its 30-year lifetime matches very well with the long-lived assets that ships are. Beyond this, the technology is economical, has a low total cost of ownership, and is very scalable from the kilowatt to megawatt. So the specific opportunity we're addressing in the maritime sector is a 27 billion euro opportunity for us, where we could generate up to 135 tons of avoided CO2 savings. If we expand our technology more broadly and look at the overall waste heat to cooling market, we could generate 130 billion in annual electricity savings were our technology deployed broadly. And as we move on, scale the technology, bring efficiency up and costs down, we could look at addressing the global cooling and refrigeration market, which already accounts for 25 to 30% of global electricity consumption, and where there's going to be tremendous growth in the next year. So in specific terms, we have to come back to ships. So looking at a specific example of a ship with Harima Sleipner, we looked at an example where we could install our technology for a total cost of 1.6 million, generating a payback time of 3 years, reducing emissions by over 2,500 tons of CO2, and reducing OPEX by nearly 600,000 euros per year. All of this coming from a 1 megawatt installation of our technology. So our technology is currently deployed in a few applications at a small scale. These all prove that the claims we make about our technology are substantiated, but we need to do one key thing to expand the market. We need to go bigger. So we need to go from our current 25 to 40 kilowatt device to one that will put out 100 to 200 kilowatts, where we take advantage of economies of scale to bring the payback times down by 66%, or up to that. And so the key thing here is sustainability is nice, but we need to have a viable payback time so that customers will invest in our technology. To scale the technology, we've put together a coalition of partners that will help us with the first install, with production, and with some key components like custom heat exchangers. Looking on a per unit basis, to summarize, if we look at the overall lifetime savings on a per module basis, we're talking about up to €1 million of savings over their lifetime, 15,000 tons of CO2, 21 tons of particulate matter, and 175 tons of nitric oxides. Now, this is all pretty tremendous, and keep in mind that each ship will likely have multiple modules. So the potential impact we can have is quite huge. Coming back to the beginning, just in the maritime sector, we could look up to reductions of 135 million tons of avoided CO2, tremendous OPEX savings, and tremendous reductions in terms of particulate matter, sulfur dioxides, and nitric oxides. But that's just getting started. We have a wide variety of other potential applications in the future, maybe looking at solar cooling for buildings, a wide variety of use cases in industries, off-grid solutions, and many more that we continue to investigate. We have a team that has a diverse set of competencies and is well prepared to scale our company and fulfill the promise of our technology. I look forward to discussing the way that Green Challenge can help us accelerate our impact, and we're open to share our broader business plan, slide decks, and any other information that is necessary. Thank you for your time and consideration.